Okay, so in this problem here we have data given for calories consumed for 20 toddlers and the average number of minutes that the toddler spends at the table where lunch was served. So time is the explanatory variable and calories consumed is the response variable. And we look at the scatter plot given, we notice we have not the strongest association in the world, but we could draw a line of best fit through there, and we could see we have a negative association, which means as time increases, calories tend to decrease. Maybe the kid sits at the table and doesn't like what's being served, so he sits there and doesn't eat. Okay, that could be a possibility. Okay, again, that would be speculative, but it is possible. So the first thing we got to do is find the correlation. So the first thing we got to do is make sure we have a linear relationship. If we don't have a linear relationship, then correlation doesn't apply. This is a linear relationship. So we're going to go to our calculator, and I already put my data in, stat edit, and L1 is time, and L2 is calories consumed. So we're going to go to stat calc, and I'm going to go down to number 8, linear regression a plus bx. Now if you want to use number 4, that's okay. The thing is, you got to make sure that your diagnostics are on. If your diagnostics are not on, you got to go to second catalog and scroll down the diagnostics on and make sure that they're on, or else it will not give you correlation. And linear regression a plus bx, and my stuff's in L1, L2, so that is the default, so I don't have to push anything else. So if you're in any other lists other than L1 and L2, you have to tell it what list the explanatory variable is and then the response variable. So I'm going to push enter, and what it gave me is A is the y-intercept and B is the slope, and R squared we'll talk about, but that's about variation, the percent of variation that this least squares regression line explains, and R is the correlation. So as we saw in the scatter plot, we have a negative correlation, and it's not really close to -1. It's like -0.65, which means it's moderate. It's not weak, it's not strongest, but it's moderate. So what is our correlation? Our correlation is -0.65, and that is a moderate. So A, R equals -0.65, moderate, negative, linear association between time in minutes and calories consumed. Okay? Alright, so the next question is, suppose we record the data in hours rather than minutes. Okay. Well, you already may know the answer to this question, but I'm just going to prove it to you. Okay, so in L3 here, what I did is I took the minutes and divided by 60. So that's how many hours we would have. So 21 minutes is 0.36 hours. Okay. 30 minutes right here, the second one, is about a half an hour, so it's like 0.5. So now what I'm going to do is I'm going to go back and I'm going to calc, and I'm going to go down to number 8, and now my explanatory variable is L3, so that's in hours, comma L2, and I calculated it, and guess what? Correlation did not change, and that's because correlation is calculated with z-scores. Okay, and what happens is, remember our z formula is x minus x bar over the standard deviation. Okay, and what happens is these z-scores, each of these z-scores do not change. Your mean will change, okay, your standard deviation will change, but that ratio will not change. So when we calculate correlation, we use z-scores, and if we switch units from minutes to hours, the correlation does not change. Okay. C says write a sentence or two explaining what this correlation means for this data. Okay. So, I think we already did that. You know, again, we have a moderate negative linear association between time in minutes and calories consumed. Or we could say we have a moderate negative linear association between time in hours and calories consumed. Okay, that's what correlation would mean. Okay, and then the last one, D, one analyst concluded it's clear from this correlation that toddlers who spend more time at the table eat less. Evidently, something about being at the table causes them to lose their appetites. Explain why this explanation is not appropriate. Well, one thing, association does not imply causation. You could have a very strong association, it doesn't matter, okay? It does not mean that the explanatory variable causes the response variable to happen. It just means that there's a very strong association between the two, because we have things called lurking and confounding variables, okay? So there's no proof that time causes kids to eat less. It could be another variable there that we don't know about. Maybe what's served causes them to eat less. Okay, maybe maybe there's things that are distracting them from eating, so they don't feel like eating. Okay, the television is on or something. I mean, we don't know. There could be a myriad of things, but that person's statement is definitely false.